My dear students, in the previous class we have studied the introduction of the basic concepts, that is coordinate axis, coordinate planes and coordinates of a point in space, coordinate planes, how to indicate the coordinates of a point in space, and equation of coordinate axis, coordinate planes, and then distance formula, how to find the distance between 2 points given in space, that is like x1 y1 z1 x2 y2 z2, and then section formula, that is if a point R divides the line joining 2 points P and Q in the ratio m:1 internally, then how to write the coordinates of the point R, that is what section formula. Then suppose the ratio is k:1, then this formula we make use of while doing problems, and then the midpoint formula, that is here, this if R is the midpoint of PQ, then how to get the midpoint, and then some simple problems, not of these are not of examination standard, but how to calculate distance between 2 points, these type of problems we have studied, and this problem you can expect in the examination. Suppose R divides the line joining this P and Q in the ratio 3:2 internally, then coordinates of the point R is given by this, and the ratio, and that is what. And one more here, that is to find the midpoint, very simple, and this one to find the ratio divided by yz plane. So instead of yz plane you may have some other plane, also we can do it. After writing the coordinates of the point R, you have to substitute these values of these coordinates in the given equation of the plane, then also you can get the value of k. That is another problem, I will give it in the exercise. And this is how to find the centroid of the triangle with vertices x1 y1 z1 x2 y2 z2 and x3 y3 z3. That is in this form I explained. This is also based on section formula only, and based on the definition of centroid, that is the G divides the median CL in the ratio 2:1. Based on that we are able to get the coordinates of the centroid in this form, and then that is about the very basics. But here this is very important, direction cosines. I have given the definition of direction cosines. Direction cosines refers to the line in space. Suppose a line makes an angle alpha with x axis, beta with y axis and gamma with z axis. Then cosine of these angles, that is cos alpha, cos beta, cos gamma, are called direction cosines of the line OP, usually denoted by LMN. Then here the direction cosines of x axis, y axis, z axis. Okay, I will explain that here. Yes, the direction cosines of x axis, y axis and z axis, I will just tell you, you should know it. See here, this is x axis, say this is y axis and z axis, or you can take x axis, y axis, z axis like that, no harm, which is x axis, which is y axis and all, this is origin. See here, suppose if you take the line here OP, that makes an angle alpha with x axis, beta with y axis and gamma with z axis, that is what. Then cos alpha, cos beta, cos gamma are called direction cosines of this line in space. Actually the line will be somewhere here, you draw a line parallel to that through the origin, then you will be getting like this. Now we shall see what are the direction cosines of this coordinate axis, x axis, y axis, z axis. That is like this. See this, suppose I explained in the previous class, suppose this OP coincides with x axis, then the angle alpha becomes 0 and x axis becomes, makes an angle 90 degree with this and also 90 degree with this. So for x axis, alpha going to be 0, beta is going to be pi by 2 and gamma is also going to be pi by 2. seems I explained in the previous class itself. Then you see cosine of these angles, cos 0, cos 90 and cos 90, another here. See here cos 0 is 1, you know it, and these two become 0. See 1 0 0 are going to be the direction cosines of x axis. Similarly, for y axis, suppose this line coincides with y axis, beta becomes 0 and the other two angles becomes 90 degree. In that case, the direction cosines of y axis are going to be 0 1 0. And for z axis, suppose same thing, suppose this line coincides with z axis, then gamma becomes 0. See, it is coinciding like this, gamma becomes 0 and it makes an angle 90 with y axis, 90 degree with x axis. In that case, the direction cosines are going to be 0 0 1. This you should remember. Now you come to one important theorem is here. If LM and R the direction cosines of a line OP equal to R, then the coordinates of the point P are going to be LR, MR, NR. Very important. I will make use of this property while finding the angle between the two lines. And another very important property, throughout solid geometry we will use it, sum of the squares of the direction cosines of any line is always unity. That is L square plus M square plus N squared equal to 1. And you may expect this in the examination. For this, just see the figure. Say this is the line OP. Okay, the direction cosines of OP, say given LMN, and this distance is R. Then the problem is the coordinates of this point P is XYZ. Okay, X is going to be LR, Y is going to be MR, and Z equal to NR. That's what you have to prove. That's the first case. For this, observe this figure. You draw PL perpendicular to X axis. Okay, then you assume the coordinates of this point as XYZ. Then automatically this distance OL is going to be X. And by the definition of LMN, this line makes an angle alpha with X axis because L is cos alpha. Then it's a right angle triangle. It's a right angle triangle. So you can go for cosine of this angle. Cos alpha is going to be OL divided by OP. That's I have given here. You just see this here. In the triangle OPL, cos alpha is OL by OP. Then substitute for OL, it's X and OP is R. So I am interested with X, so X is LR, very clear. Exactly similar to this, instead of having X axis, suppose if we have Y axis here, say here X axis, here Y axis, no problem. Then automatically this angle becomes beta and this distance becomes Y. So exactly similar to the previous one, you can get that cos beta equal to Y by R, so Y equal to MR like that. Similarly, suppose X axis, Y axis, Z axis, this is Z axis. Then this angle becomes gamma and this distance becomes R. In that case, once again cos gamma equal to, you will be getting Z by R from the right angle triangle. So you will be getting Z equal to NR because cos gamma is N. That's what here I explained. Here, just see this. X is LR. Similarly, you can get Y equal to MR and Z equal to NR. It's a very important property. So then the second one is this property L square plus M square plus N squared equal to 1. The sum of the squares of the direction cosines is going to be 1. Okay. Suppose LMN are direction cosines of some line, any line, then L square plus M square plus N squared equal to 1. For this, you said just see this distance OP. That's R. Okay, R equal to OP. Okay. But that R I can get by distance formula here. R is square root of x minus 0 whole squared plus y minus 0 whole squared plus z minus 0 whole squared. That's OP equal to, I will be getting this root of x square plus y square plus z square. This is only distance formula, distance of P from the origin. I explained in the previous class. Then square it, say OP squared equal to this root will go. Substitute for OP, it is given here R. So R square equal to, you see this x, y, z I have got just now, x is LR, y is MR, z is NR. Substitute here and see that I will be getting this R square, R square, R square here, left hand side is R squared, divide through by R square, I will be getting 1 equal to L square plus M square plus N square. Like this you can prove this. It is an important property and you can expect in the examination. And next see proportional direction cosines. This is our direction ratios. It is another definition based on LMN. Suppose the direction cosines of a line are LMN, there exist 3 numbers A, B, C. such that L, M, N are proportional to A, B, C. Say L proportional to A, M proportional to B, N proportional to C, like this. Then A, B, C are called proportional direction cosines of that line whose DCs are L, M, N or direction ratios. So that is like this, L by A equal to M by B equal to N by C. Then see here we can get L, M, N knowing A, B, C. Suppose if you know direction ratios of a line, you can get the actual direction cosines L, M, N. For that you see it's a property, that's a rule, component dividend rule. See that says you take the square of sum of the squares of the numerator with square root, and here in the denominator also do the same operation, square root of A square plus B square plus C square, and then these ratios equal to this ratio. That's a rule. But here I have proved just now L square plus M square plus N square equal to 1, and the denominator you can give sigma summation symbol, summation A square, that is sigma A square. So it is A square plus B square plus C square. So numerator is 1, so I will be getting 1 over this. Then cross multiply, see L by A equal to this, therefore L equal to A by root of sigma A squared. Similarly M equal to B by root of sigma A squared. See this M by B equal to this B will come here and I will be getting M. Similarly N by C equal to this, so N equal to, see this, C by root of sigma A squared. That means knowing A, B, C, you can get the actual direction cosines of that line. That is very important. And one more property, we will be using all these things while doing problems. Okay, here let L, M, N be the direction cosines of a line PQ, say here PQ is equal to R, the distance is R, and this angle I have taken it as alpha because we are assuming the direction cosines of this line as L, M, N, say. Then see this, how to prove the direction cosines of this line are proportional to x2 minus x1, y2 minus y1, z2 minus z1. That means the direction cosines of this line joining these 2 points are going to be, say, x2 minus x1, y2 minus y1 and z2 minus z1. That is what you have to prove. Okay, that is knowing these 2 points on the line, I can get the direction ratios and direction cosines. That is also very important while doing problems. So here see this point is x1, y1, z1, this point is x2, y2, z2. What you have done is you draw PL and QM perpendicular to x axis here, and you draw PN perpendicular to QM, that is all. And then you see this LM is going to be PN, see this LM is PN, and I said this angle is alpha actually by definition of LMN, and this distance PQ is R. You observe here some coincidence is there, alpha is angle and R is the distance PQ. I have taken here very clearly, see this PQ is R. Okay. Then you see this LM is nothing but this PN. So observe this, I am going to calculate this PN, okay, that is LM. In this, see this point is Q is x2, y2, z2 means you see this distance OM is going to be x2. Okay, and the C point P is here x1, y1, z1, and that means this distance OL is x1. So this OM is x2 and this OL is x1. So I want LM, it is x2 minus x1. So PN is going to be x2 minus x1. Okay, that's enough for me. Now in this, it's a right angle triangle, this PQN, there you take cosine of this angle, cos alpha. See, I have given here everything. See, if I take cos alpha here, and you see by the definition of cosine, cos alpha is adjacent side is Pn and the hypotenuse PQ, so Pn by PQ will get. So here cos alpha we know it's L, and I told you this Pn is nothing but x2 minus x1, I have calculated here, and this distance PQ is R. So because this R is the distance between P and Q, it's a constant, so 1 by R is another constant, therefore I can say L proportional to x2 minus x1. Exactly similar to this, you can prove M proportional to y2 minus y1. I mean M is y2 minus y1 by R. If you take just this x axis as y axis, then this distance becomes y2 minus y1 and this angle becomes beta. Just similar to this, you can go ahead, I will be getting cos beta here. Cos beta is going to be once again this y2 minus y1 by R. So once again now that R remains same, so I will be getting M equal to y2 minus y1 by R. So that M is proportional to y2 minus y. Similarly, this N proportional to z2 minus z1. Suppose if we take it as z axis, and these distances will be in terms of z. I will be getting Lm as z2 minus z1, so Pm is z2 minus z1, and this angle is going to be gamma. Then you will be getting cos gamma equal to, you will be getting exactly similar to this, I will be getting here z2 minus z1 by r, but cos gamma is n, therefore n proportional to z2 minus z1. Say that proof not given here, but that is more than sufficient. Once you prove L equal to x2 minus x1 by r, enough, the other two you can directly write. So it is very clear, the direction cosines of a line passing through the points p x1 y1 z1 and q x2 y2 z2 are given by x2 minus x1 y2 minus y1 z2 minus z1. They are nothing but a, b, c. Then you can get Lmn using this formula. That is very important property. Next, the very important is this, you can expect in the examination. See, the direction cosines of two lines whose direction cosines are given by L1 m1 n1 and L2 m2 n2, okay, is given by this formula, cos inverse of L1 L2 plus m1 m2 plus n1 n. You can expect this proof in the examination, many times appeared in the examination, and based on this we can do many problems. So here you have to think two lines in space, say A, B, and think of two lines in space, say x axis, y axis, z axis, like this, origin. Say here two lines somewhere here, they are in space, the two lines are in space. You can think like this, two lines are in space, okay, the DCs of this line is L1 M1 N1, DCs of this line L2 M2 N2. So I have to find the angle between these two lines. For this what we do is, we bring them to one plane like this, okay, they will intersect at a point, and you draw a line parallel to this through a point, and draw a line parallel to this through the same point. So in this case, that point is origin. Okay, then the angle between these two lines is going to be angle between these two lines. We have drawn parallel to them because it is just like this. That is what. Then see the angle is here, that I will calculate because the directions remain same. So direction cosines remain same. And one more thing here, I am going to assume while drawing like this, I am assuming the length of these two lines as 1 unit. See, the length is not at all affecting the angle between these two lines, whether it is 1 unit or 100 unit, the angle is not affected. So that is one of the assumptions. So here it is the line AB, say, and CD here, and the DCs of this line L1 M1 N1 and DCs of this line say L2 M2 N2, like this. Draw line parallel to AB, say here OP, and draw another line parallel to CD somewhere just like this. So this is OP and this is OQ, each of unit length, that is what my assumption. So OP is going to be 1 unit and this is 1 unit. 1 unit means 1 centimeter or 1 kilometer, just like that, and they join this and see this angle. So angle between AB and CD is going to be angle between OP and OQ. So I will assume this angle as theta. That is what the figure. Draw OP parallel to AB and OQ parallel to CD, each of unit length through the origin. This is your origin, this is the origin. So angle between AB and CD is going to be angle between OP and OQ. That is what the case. So here, how to find the angle, the theta here? See, based on the previous book work, see, once the distance is 1, okay, and the DCs of this line are L1, M1, N1, so the coordinates of this point, it is just like LR, MR, NR, like that. See, the DCs are L1, M1, N1, so L1 into 1, so I will be getting L1. M1 into 1, M1. N1 into 1, N1, see, like this. So the DCs of this point is going to be L1, coordinates of this point is going to be L1, M1, N1. Similarly, the DCs of, the coordinates of this point is also are also going to be, see this, L2 into 1, M2 into 1, N2 into 1, just like LR, MR, NR. So it is going to be L2, M2, N2. Because LMN are known and the distance is known, I can write the coordinates of these 2 points. Now observe, this is a triangle where these 2 sides are known, 1 unit. Suppose if I get the side PQ, then I can go for cosine formula to find the angle theta, that is what. And here to find PQ, we go for distance formula, that is what here, see, I have explained, we will go for the distance formula. You just see here distance between these 2 points, they are just like 2 points, P with L1 M1 N1 and Q with L2 M2 N2. See, the distance between PQ is given by just like x2 minus x1 whole squared plus y2 minus y1 whole square plus z2 minus z1 whole square. Just like that, I am getting L2 minus L1 whole square plus M2 minus M1 whole square plus N2 minus N1 whole square. That is what I written there. Then simplify it, square both sides, this root will go, and see this, you will be getting L2 minus L1 whole squared etc. Expand, just expand by A minus B whole squared formula, I will be getting L2 squared plus M2 squared plus N2 squared and L1 squared plus M1 squared plus N1 squared, and this minus 2AB form, minus 2L1 L2 minus 2M1 M2 minus 2N1 N2, it is only A minus B whole squared formula, but here you see this sum, L2 square plus M2 square plus N2 square is going to be 1, because L2 M2 N2 are direction cosines of one line, that is a CD, and similarly here L1 M1 N1 are direction cosines of another line AB. So this sum is also going to be 1, I have just now derived. Then it is 1 plus 1, you will be getting, see this 1 plus 1, and here I will just use sigma symbol, instead of writing all the 3 terms, I will be writing minus 2 times summation of this product L1 L2. So here it is 1 plus 1 2, and here also 2, remove the 2 common, then you will be left with 1 minus summation L1 L2, that is what. So like this you are able to get PQ square. Once you get PQ square, see from the triangle OPQ, see that blackboard in the figure, see in this figure, this is what the triangle, see I am going to calculate this angle theta. It is a cosine formula. See, it is a cos theta. Cosine of this angle is going to be OP square plus OQ square minus PQ square divided by twice OP into OQ. This is what the cosine formula says. So based on that, see here, this equal to, see OP square 1 only, OQ square, see that is also 1 and PQ squared, you know it, you got it, that is plus 2 times, minus 2 times 1 minus sigma L1 L2 like this. This is what I got, divided by, it is 2 only, because OP is 1 and OQ is 1. Then see this, here 1 plus 1, it is going to be 1 more 2. Then see here 2, you remove the 2 common and it cancels here. So on simplification you will be getting 1, this is 1, so minus 1 and minus plus, and see that sigma L1 L2 I will get here. So divided by 2 cancelled, you have only this, and 1 also cancels here. So you will be getting this cos theta equal to summation L1 L2, just see this. So actually there ends the problem, because theta is cos inverse of this, theta is cos inverse of that. So I will write that, see cos inverse of sigma L1 L2 can expand, L1 L2 plus M1 M2 plus N1 N2, like this. That is what the required formula many times appeared in the examination. You have to remember this. Here I will get you 2 particular cases. Suppose the 2 lines are perpendicular, that is AB and CD are perpendicular, that is with DCs L1 M1 N1 and L2 M2 N2. Then you see that cos theta is going to be cos 90, perpendicular theta is 90 degrees, so cos 90 becomes 0. So we will be getting this condition summation L1 L2 equal to 0, because cos theta is going to cos 90 equal to 0. And see, I am getting very important condition here, L1 L2 plus M1 M2 plus N1 N2 equal to 0. If these 2 lines with DCs L1 M1 N1 and L2 M2 N2 are perpendicular, then you can easily write L1 L2 plus M1 M2 plus N1 N2 equal to 0. Or this condition is true, then you can say immediately the given 2 lines are perpendicular. Similarly, suppose the 2 lines are parallel, then you will be getting the direction cosines are equal, that is you will be getting L1 equal to L2. If the lines are parallel, then you will be getting L1 equal to L2, M1 equal to M2, n1 equal to n2. Separate proof is there. We can prove it because when the lines are parallel means they have the same direction. They have the same direction. So when we draw a line parallel to these two through the origin, they will just coincide like this. I mean automatically L1 equal to L2, M1 equal to M2, N1 equal to N2. Actually theory is there, but that proof is not necessary. That's what when the two lines are parallel, their direction cosines are same. Next, with the direction ratios also it is better to know. Suppose the two lines are with direction ratios A1, B1, C1 and A2, B2, C2. That is, once you know A1, B1, C1, you can get L1, M1, N1, and similarly here you can get L2, M2, N2. You can go back to the same formula actually. You can get the angle between the two lines with the DRs A1, B1, C1 and A2, B2, C2 because you are able to get L1, M1, N1 and L2, M2, N2. Okay, here once again the perpendicularity condition when theta is pi by 2, that is when the lines are perpendicular with the DRs A1, B1, C1 and A2, B2, C2. So I will be getting just similar to sigma L1, L2, I will be getting sigma A1, A2, 0. That is this condition A1, A2 plus B1, B2 plus C1, C2 equal to 0. It is very important. When the two lines are perpendicular with the DRs A1, B1, C1 and A2, B2, C2, then we have this condition. Vice versa, if this condition is true, then the lines with the DRs A1, B1, C1 and A2, B2, C2 are perpendicular. And similar to that here, when the lines are parallel, then you see A1, B1 with DRs A1, B1, C1, A2, B2, C2. Here, don't say A1 equal to A2, B1 equal to B2, C1 equal to C2, as in the case of direction cosines. Here, you will be getting only this condition A1 by A2 equal to B1 by B2 equal to C1 by C2. I mean, if the two lines are parallel, then their direction ratios are proportional. Because if you go for component A dividend rule here, I will be getting root of summation A1 square plus B1 square plus C1 square. That is not 1. And similarly here, summation root of A2 square plus B2 square plus C2 square, that is not 1. So you cannot say A1 equal to A2, B1 equal to B2, C1 equal to C2, but you can come up to this stage. Whereas in the case of direction cosines, you can definitely say L1 by L2 equal to M1 by M2 equal to N1 by N2, correct? Then you can prove that is equal to 1. So I will be getting L1 equal to L2, M1 equal to M2, N1 equal to N2. So these conditions you have to remember. See, this is what the case I have explained already. When the lines are parallel, see the condition is here. Based on this, you have to concentrate towards the problems. Problems you can expect in the examination. One derivation you can expect is the angle between the two lines in the form of cos inverse of L1 L2 plus M1 M2 plus N1 N2, that derivation. Okay. Then you see I will give some simple problems based on the direction cosines and their properties. See the first one. If a line makes angles alpha, beta, gamma with x axis, y axis and z axis respectively. That means a line makes an angle alpha with x axis, beta with y axis, gamma with z axis. Then you have to prove that sin squared alpha plus sin squared beta plus sin squared gamma equal to 2. I remember even this problem appeared in the examination. It is a very simple case. If a line makes angles alpha, beta, gamma with the coordinate axis, then cos alpha, cos beta, cos gamma are direction cosines of that line. They are nothing but LMN. Then see, we have proved just now L square plus m square plus n squared equal to 1. See here, L square means cos squared alpha, m squared cos squared beta, n square cos squared gamma. See that different notation, we will be getting 1. Then use trigonometric relationship between cos and sine. See, cos squared alpha is going to be 1 minus sin squared alpha, and cos squared beta similarly 1 minus sin squared beta, cos squared gamma 1 minus sin squared gamma. And see here 1 plus 1 plus 1, 3, and take this 1 to the left side. So 3 minus 1 is going to be 2, and minus sin squared alpha minus sin squared beta minus sin squared gamma, take it to the other side. So you will be getting this. So I remember even this problem appeared in the exam, very easy to get marks. So one more, see here, if a line, see based on this idea only, if a line makes an angle 45 degree with x axis, 60 degree with y axis, find the angle of inclination with z axis. That is knowing one of the angle, knowing two of the angles among 3 alpha, beta, gamma, you can get the other one. It is based on this condition only, cos squared alpha plus cos squared beta plus cos squared gamma equal to 1. So, based on that condition, we are able to get the angle here. The required angle is actually gamma, because alpha and beta are given. So, with x axis 45 degree means alpha is given, 60 degree with y axis means beta is given. See, you have to find that gamma. See, it is very clear. See, alpha 45, beta 60, you have to find gamma. So, go for this formula property. Today only I derived it. L square plus m square plus n squared equal to 1. So, see this L square means cos squared alpha, cos squared 45, cos squared 60, cos squared gamma. Just simplify it, you know, cos 45 is 1 by root 2, square it, I will be getting 1 by 2, cos 60 half. So, when you square it 1 by 4, see this equal to 1, you simplify it, I will be getting cos squared gamma equal to 1 by 4. Once again I am getting cos gamma equal to half, so gamma equal to 60. You may get equal angles sometimes depending on how you have taken alpha, beta, gamma. So, that is another problem. And you see this problem, most important for the past so many years I have observed this problem in the examination. So, very familiar. See, if a line makes angles alpha, beta, gamma, delta with the 4 diagonals of a cube, prove that cos squared alpha plus cos squared beta plus cos squared gamma plus cos squared delta equal to 4 by 3. For this, see, very familiar problem in the examination. See this figure, cube. A cube means all the edges are same. So, here see this construction you should know. So, here OA is one, the OA, OB, OC, they are called coterminous edges of this cube. See, OA equal to OB equal to OC. Okay, if you take this condition, then automatically this figure will become a cube. So, here I have taken OA equal to OB equal to OC equal to A, some constant I have taken, be the coterminous edges of a cube. Okay, you are familiar with the figure cube, it is a solid. I told you a solid is one having all the 3 length, breadth and thickness. See this OA, length, breadth and thickness, just like that, all the 3 are there. So, take OA, along OA you consider this as x axis, this OB extend along y axis and this OC as z axis, and this origin you know it, coordinates are 0, 0, 0. And then you see when you see these edges A, see it is on x axis. So, distance OA is A, small a, and because it is a point on x axis, the y and z coordinates are 0. And similarly see B, it is a point on y axis and the distance OB is A. So, x coordinate, z coordinate 0. So, distance along y axis is A, and similarly this OC, it is a point on z axis. So, only z coordinate will be there, that is A, because this OC is A and x and y are 0. Like this, when you come to this point G here, see it is a point in xy plane. So, it will have x and y coordinates and z coordinate is 0. You just see this, this OA is x and move upwards, this is y. So, both are OA and this AG are going to be A only. It is a point in xy plane. So, z coordinate is 0, very clear. And similarly, you see this point is a point in yz plane. YZ plane. So, x coordinate is 0 and these 2 coordinates y and z, see this is y and this is z. Okay, this is z along z axis, see this is A, this is also A, like that. This is A, and these vertical lines or horizontal lines, you see these lines, they are all A only. So, you will get 0 A. And you see this point, it is in xz plane. So, y coordinate 0, say this distance is A and this distance is also A, this is Z and this is X, and y coordinate is 0. So, this, and observe this point P, this point P is in space, point P is in space. So, it is having all the 3 distances. Okay, you see this is A, this is also A and this is also A, like this. So, this distance you have to observe, it is coming towards you. So, all the 3 distances are there for this point P, because it is a point in space. So, all the 3 distances are A only. See the perpendicular distance drawn from the point A. See this P F, you can see drawn to xz plane. Okay, this is y, and this is the distance PG drawn perpendicular to xy plane. You see that is also A, like that. And see this PE, that is drawn perpendicular to yz plane. So, these three perpendicular distances indicate the coordinates of this point. That is what I explained in the very first class, how to indicate the coordinates of a point in space. I hope you have followed how to write the coordinates of these corners of this cube, and this origin is starting point 0 0 0. So, it is the starting point. So, about the figure you should know it, and here concentrate towards the 4 diagonals. So, here the 4 diagonals are, one diagonal is OP, see this OP, and this A, this one you just see this A, E, different, you see here I have written the 4 diagonals are OP, AE, BF, okay, here BF and CG here. They are going to the 4 diagonals. For a square or a rectangle you will have only 2 diagonals. When you move to the solid figures like cube, you will have 4 diagonals. You just see this. So, now you have to calculate the direction cosines of these 4 diagonals. Okay, here the direction cosines of the 4 diagonals are here I have given based on the previous book work. See, if you want the direction cosines of OP, see, I have proved just now, it is just like x1 y1 z1 x2 y2 z2, and this distance OP you can get it. Okay, otherwise get the direction ratios as a minus 0, a minus 0, a minus 0, I will be getting a. Then you can move to the calculation of direction cosines. It is just a by root of sigma a squared. You see this sigma a squared is going to be in this case a square plus a square plus a square, because a b c are nothing but a. So, all the 3 will become same. So, when you simplify this, see, it is going to be 3a square. So, root of 3a squared. So, a squared will come out as a cancels. So, you will be getting 1 by root 3, 1 by root 3, 1 by root 3. You see, these are direction cosines of this OP. Similarly, for this another line AE, for AE you see that, for AE, see the point AE here, AE, see, you have to subtract like this, see 0 minus A minus 0, A minus 0. First one 0 minus A, I will be getting negative sign. The other two are positive only, except that no other changes. Okay, if you want a CG, see the point CG is here, see A minus 0, A minus 0 and 0 minus A, and see the last one is going to be negative, like that. And the other one, if you want, see BF, see here BF, see this, see A minus 0, 0 minus A and A minus 0, see the middle one is going to be negative. Okay, that is all. Like that you will first get the direction ratios and then direction cosines. That is what here I did. See, I got direction ratios first, minus a, like that, then you convert them into DCs. The denominator remains same because this is the distance. Okay, length of the diagonals are same. So, in all the 4 cases I will be getting the denominator same. It is going to be root of 3a squared only. So, I will be getting that a cancels, and see that first one is going to be minus, other 2 are same. Similarly, for the next one, middle one is negative and the other 2 are same, and this one. Like this, you must know how to calculate the direction ratios and also direction cosines when 2 points are known in a straight line. Based on that, you are able to get the direction cosines of all the 4 diagonals, very important. And then my problem is there exists a line, say the DCs are LMN, that makes an angle alpha with one diagonal, that is OP, and beta with AE, and gamma with BF, and delta with CG, just like that respectively. Then you see that what is cos alpha. So, I will write here. See, just like this case, see, when you have 2 lines with the DCs L1 M1 N1 and L2 M2 N2. So, then I have given just now the formula cos theta is going to be L1 L2 plus M1 M2 plus N1 N2. This is a formula I derived. Now, there is some line whose DCs are LMN. I have another line that is the diagonal OP. So, OP makes an angle alpha with this line, that is what my assumption, I will take it as alpha. Here the DCs of OP are known, it is 1 by root 3, 1 by root 3, 1 by root 3, you got it. Then you see, based on this formula, I will get cos alpha. What is cos alpha? See this, just like L1 L2 plus M1 M2 plus N1 N2. See, L by root 3 plus m by root 3 plus n by root 3. See this, L by root 3 plus m by root 3 plus n by root 3. Or you can remove 1 by root 3 common, it is 1 by root 3 into L plus m plus n. That is what. See, you got cos alpha. Similarly, if you go for cos beta, the change is only here. The first one is going to be negative. So, instead of the next diagonal, that is EAE, see the change is only here. I will be getting minus L by root, I will write here otherwise, 1 by root 3 same and see minus L plus m plus n. Next, similarly cos gamma, that is the next diagonal, that is BF. If you take 1 by root 3 will come out and see the middle one is going to be negative, L minus m plus n. And the last one, when you take angle between that line with the DC's LMN and CG, it is going to be cos delta, I will write here, that is going to be 1 by root 3 remains same and see n is negative, L plus m plus n minus n like this. This is the way of finding these angles, cos alpha, cos beta, cos gamma, cos delta. See, now we have to prove the sum of the squares of this cos alpha, cos beta, cos gamma, cos delta equal to 4 by 3. That is only squaring cos alpha, square it. See, cos squared alpha is going to be, I will write here only because I have not given that simplification. See, cos squared alpha, how you get? It is going to be, see, 1 by 3 squaring this, and it is going to be a plus b plus c whole squared formula. So, you know that it is L square plus m square plus n square, high school portion, and 2 times LMN plus 2 times Mn plus 2 times Ln. So, just like a square plus b square plus c square plus 2ab plus 2bc plus 2c. Observe here, this is one I have proved just now. So, it is going to be 1 by 3 into 1 plus, see this 2Lm plus 2Mn plus 2Ln. See this is cos squared alpha. That is what I want. And now you see that you are able to, you need not show all the steps for the simplification. Once you know cos squared alpha, you are able to write cos squared beta, cos squared gamma, cos squared delta directly, because see in this result, see for cos beta L is negative. So, when you square here minus L square, it is plus only. So, this will not change, it remains same. Only see here that L, wherever you find L, you replace it by minus. So, you will be getting cos squared beta equal to 1 by 3 into this remains same 1, but here L is negative, observe. So, minus 2 Lm, this remains same plus 2 Mn, but minus, see minus 2 Ln. Next cos squared gamma, see this cos squared gamma equal to once again 1 by 3, this one remains same, see m is negative. So, it is wherever you find m, it is negative, minus 2 Lm, and here minus 2 Mn, because m is negative and 2 Ln remains same. Last one, say cos squared delta, see here n is negative, observe. So, 1 by 3 into, when you square it, 1 by root 3 squared is 1 by 3 and use that formula 1 here, but wherever you find n, you change it to negative here. See, it is plus 2 Lm and these two are negative, minus 2 Mn minus 2 Ln like this. This. Now, you have to add this, all the 4 results. See, cos squared alpha plus cos squared beta plus cos squared gamma plus cos squared delta, when you add it, you see this cos squared alpha plus cos squared beta plus cos squared gamma plus cos squared delta, say this is equal to, see when you are adding this plus this plus this plus this, okay, 1 by 3 is common, you can keep 1 by 3 common, because the 1 by 3 is common because you are adding. And here after keeping 1 by 3 common, you see here 1 plus 1 plus 1 plus 1, 4, and remaining you just observe, because we are adding, see 2 Lm minus 2 Lm cancels, okay, and here plus 2 Ln minus 2 Ln cancels, okay, and here plus 2 Mn, see minus 2 Mn cancels, and here plus 2 Mn minus 2 Mn cancels, minus 2 Lm plus 2 Ln. See that all these terms cancels, and final answer is only, because remaining cancels, you will be getting 0. See the answer 4 by 3. And that is what the proof this observed for the past so many years. This proof is very familiar in the exam. But as a corollary, I would like to give one more case here. See, that is this. If you take sine squared alpha plus sine squared beta plus sine squared gamma plus sine squared delta equal to, it is going to be 8 by 3. For that, you can just replace cos squared by 1 minus sine squared. See this, 1 minus sine squared alpha, right here. Here, 1 minus sine squared alpha plus 1 minus sine squared beta plus 1 minus sine squared gamma plus 1 minus sine squared delta. This is equal to have 4 by 3. And see very clear, see here we are having 1 plus 1 plus 1 plus 1, 4. Okay. And take that 4 by 3 to the left side is 4 by 3. And you see these minus sine squared, etc. Take it to right side. I will be getting sine squared alpha plus sine squared beta plus sine squared gamma plus sine squared delta. You just see this. And here take LCM, it is 12 minus 4, 8 by 3. See that it is over. You can write sigma sine squared alpha here if you are interested. That also appeared in one of the examinations. And another important problem, very familiar in the exam, search your question papers, many times appeared in the exam. That is how to find the angle between the two diagonals of a cube. Okay, same figure up to the calculations of direction cosines of any two diagonals. Don't calculate the direction cosines of all the 4 diagonals. See, you see I have given here, but don't write this in the examination or repeat the entire procedure and all. If you write, who is going to repeat? Okay, you have to write all these steps, write the figure and mark the points, everything. You repeat everything what I explained in the previous problem with figure up to the calculation of the two direction cosines of two diagonals. Okay, here we have OP and AE. See, direction cosines are here. You just see here. Then angle between these two is given by, I will move to directly this formula, theta equal to cos inverse of L1 L2 plus M1 M2 plus N1 N2. So here you see L1 M1 N1 L2 M2 N2 multiply. See, 1 by root 3 into minus 1 by root 3 you multiply. So it is going to be 1 by 3 minus 1 by 3 plus 1 by 3 and it is another 1 by 3. So these two cancels, at the end you will be getting cos inverse 1 by 3. You search the question paper, I think it has carried 7 marks. Okay, compared to the previous problem, this is very easy, but many times appeared in the examination. So I think it is time up. So I will continue. I have another two classes to cover the problems based on direction cosines and all. So I will give all these some more problems are there, very important problems appeared in the exam. In the other two classes, definitely I will cover more problems which are in the interest of the examination. They are very important. These are all the problems, very important problems. Okay, this problem also very important. You see the old question paper, this type of problems also appeared in the examination. See, direction cosines of two lines are connected by these two equations. How to find the direction cosines of those two lines? Okay, that is what the method, and then we will calculate the angle between those two lines. Here some theories, I mean steps are more, but you have to get ready for this type of problems also. Okay, I will stop with this. I will give all these problems in the coming two classes. 2 classes enough to complete all the problems, and some exercise problems are here. I will cover up these also. As far as the plane is concerned, my colleague will continue. Okay, I thought of introducing the definition and the equations of the planes and all. I think how we will start, he is going to start shortly, but I will be, anyhow I will be, it may be repetition, I will be covering those things in the coming 2 classes. Okay, thank you.